Hello and welcome back to another session of Google.rs. It's Byron speaking. And it's the first session of today. Yesterday we left with basically leaving the API or writing the API, the interface for the FileLock type. And I was looking at it afterwards and was thinking, damn it, all this doesn't really work. Unfortunately, for one major reason. So this is supposed to be a convenient type, which also creates the file that we will need. It creates this lazily, so it creates it only when the lock is attempted, is what happens here, and this nicely convoluted one-liner, which is totally awesome, I think. However, this type is actually very close to this type, the lock type, even though the lock type kind of boils it down to just working on file descriptors, which is what we're actually interested in. Whereas this type will create the file whose file descriptor is used. It doesn't use the lock type though, even though, probably it should. However, as we want to keep the file open, it doesn't really make sense to use this type here just for the drop implementation. Speaking of which, the drop implementation, previously I thought there would be a way to safely remove the lock file. However, this is totally not possible, because the only reason this would be possible is if we would be able to determine if the file was actually created by us. And this is optional now, it could be there already, we wouldn't know. And there's no way to find out. So the API, even in C, doesn't tell you if it actually created the file or not. And, you could say we could test for file existence first, right? Yes, but that would be a racy situation. So we could test it, it's not there. Then we try to create it and assume it is there. Wait, maybe it's not that racy. If this would fail, but I think it wouldn't fail, because if you want to open something and we say, well, create is true, but it should fail if the file already exists, then this could be something that prevents erase, even though dealing with that correctly would still be difficult. But I think it's still going to be the same. Yeah, if it doesn't already exist. See, so I don't think there's a chance here. So what we are doing is we create that file basically unconditionally or use the existing one. But as we don't know if we created the file or not, if we own it or not, we cannot safely remove it. So this drop implementation is actually wrong. It's supposed to be self-unlock. And that's all. That's all we can do here. Voila. And we ignore the result basically. We don't want to unwrap this. So this is how the implementation would have to look like. This also means that the log files will be persistent, and we might want to hide them from view. This also means that probably we want to have one central location for the log files. I mean, we'll see, right? It depends on the actual resource that the log file is supposed to lock. So some are quite central, like the registry, creation log files. I'm talking about cargo, obviously, because that's what we do this for. So I think that will work, and that will not be racing. Now that we don't remove the file anymore, we can assume it is there. And if it's not there, we will have an error here, which will cause something to happen at least. Obviously, this is not the final one. This is just the one we provide in general. Later we will wrap this in a cargo specific one that will be a bit smart about what is supposed to be done. We are mirroring the kind of the read-write lock semantics here. Lock and try lock, which is in the read-write lock API, called write try write and read try read. Even though the question of whether we want to read or write a file, this is kind of given to us at creation time, because that affects the way we wanna open this file. And I want the file to be open just once, and we can't, if we had an API that would allow to choose like read write lock, then we wouldn't be able. Then we would have to manage kind of our open file handle and possibly close the file again and open it again in read mode, or maybe open read write right away. That would also be possible. But I don't know if the file locking would be so happy about that, because that is also affected by the access mode that we have. Because if we have a read, if you just have it open for reading, then we can have shared access to it as long as everybody is reading, right? So this is also understood by the locking mechanism. Anyway, we have to test this. And here we have this beautiful process lock, which basically calls itself here. Yeah, does it do anything special? Yeah, this is a closure because it uses T. Anyway, we can easily pass this. I'm just thinking how to rewrite this now to add more tests, because this guy just uses lock and opens the file himself. I could obviously, I could just have another interlock test which uses FileLock instead. So I don't have to touch this one, which already does what it does, because here I probably want to test read-write semantics as well, which requires a bit more logic, and this here will just get more convoluted. Interestingly, this additional logic is something we could totally do with the lock as well, with the lock type instead of the file lock type, but the lock type doesn't deal with file creation here. This is why we do it differently. Here also there is a process master which creates this file that is just passed to the kind of slave which is supposed to try to lock stuff. And yeah, that's how that goes. Interprocess file lock. And what I'm saying is that this implementation here that uses the file lock will not do this. It will have two equal parts, basically two collaborative processes which don't know who runs first, and this is an assumption we don't want to make here. And yeah, blocking semantics are also something we want to try at some point, which right now we don't have either. And yeah, regarding the interface, it would always be easier if we could have a lock function or method that would allow us to use this lock kind here to specify what we want and selects the right lock method automatically. So I think this is something I want to implement right away. Lock, any lock maybe, which takes a lock kind and returns a result as usual, and this will just do that thing here, but use the kind instead. This also means that here we will just use self any lock and therefore deduplicate that thing. That's much better. Which is lock kind blocking. Oops. And here we have lock kind non-blocking. Good. That's better. So now if you wanted to, we can more easily handle this here in our test case. Try lock, lock. And how would we call this? Any lock or lock mode, lock kind. Yeah. Lock kind lock. Well, any lock. I mean, what I like about it is that we have a 3-letter prefix, which is similar to try. But besides that, I'm not super happy. Okay, so We automatically release the lock. That's also good. And yeah, let's see. So I think we want to have we want the slave, you know, we want to pass on information, maybe about what the slave should do. So if there an environment variable is set that tells him what to do, it will be in slave mode. So and FileLock kind. It's more like this now, huh? Because it's a lock test, FileLock test, and that's the lock kind. And yeah, here we can just compare strings or something. Lock kind blocking. So if it's a blocking lock, we will use the blocking kind. It's just true or false, right? I'm just trying to parse this as integer, and it's gonna be, or as Boolean. Can I parse as Boolean? I will find out. Okay, so match and var and block file kind, and here we have the kind. This puts us into slave mode. And then we will also try to read whether it's going to be right or not right. The access mode. Access mode is right. Writer. Maybe like this. So this is something we expect to be set all the time. That is right B and var and access mode. So we unwrap it because we expect it to be set. And we want it to be a bool, so we can parse on it. And this can't fail, so we unwrap it right away. So I'm always curious about parse and where this is, on which trait that would be. Ah, see, it's not on trait, it's just implemented on string, and it's a generic. And it's pre-implemented for the basic types. I wonder how you can implement. I wonder how you can implement this for any of your types. Probably not. Maybe from string? Yeah. There must be a trait that does the same, right? But maybe it's not in this. I mean, in this case, obviously it's not like that. So if you implement the from string trait, then you can use parse. Because, yeah, now I get it. So this is what you want to implement for your own type, then you can call parse on the string, which is pretty cool. So that returns an F. Ah, nice. I like it. Nice. I love this, actually. Not only like, much stronger. Our feeling, it's love. Anyway, so where do we go? We are here, and this should yield us with the is right thing. And Oh, something is wrong here. And we might even convert it to the respective kinds right away. So what about, how do we do this? We could have a from string and implement it for the access kind. Or toString even, so we can kind of convert this easily and make sure this actually works. Yeah, let's do this. From string and toString. So let's implement these, because then we don't have to think about that anymore. Then it's done. So impl toString. Ah, wow, that is a massive file. Does it exist? toString, of course it exists. Cool. I don't know if it's in the prelude though. That would be cool if you would see, oh, it's in the prelude. So you don't have to do any kind of import. So let's do that. Impl toString for access mode. Ah, damn it. 2 spaces. I must have I think I have one spot here that makes it think that it's 2 spaces only. For instance, this one is like that. This one looks good. And then maybe elsewhere, here, it's also wrong. Yep. Let's fix this once and for all. That's now better. Okay. And this is also wrong. Probably this is where it checks it, and this is the first thing it finds, so it thinks it's just 2 spaces. Log.rs. So now it seems to figure it out correctly. Cool. toString, fn toString of a immutable borrow shall return a string. Does it return a string? Yeah. Into an own string. Yeah. As you know, we could also implement asref string, and I wonder if asref is as good for us. Because this could auto implement toString. Actually. Huh. Yeah, anyway, I'm implementing let's implement asref string, because that would be totally acceptable here. This is kind of overdoing it because we allocate a new string. Asref str asref, which returns a string, and we match on ourselves. Then it's access mode read, which shall be read, access mode write, which shall be write. Cool, there we go. And from there we can easily get to a string, and from there yeah, we get what we want, but that's already all we need. And now the inversion from str for access mode. Is it from str or from string? I forgot. From str makes sense. I would have thought that, but I wasn't sure. So fn from str, I guess. From str. So that's, oh, type error we have to set. I see. True, that can fail. Type error is what? Can I do this? The error type is a string that just says what we understand and what not. Maybe this. Yeah, maybe that. So here we get an input string and return an access mode, which is self in this case. So can we match on this? I think we can. Oh, we can. I can call it like that. So this should work, right? So we do read. That's access mode read. And we write, and it's access mode write. Nice. That should compile provided these traits exist. Maybe this one doesn't. Oh no, this one doesn't. Use std str from string, maybe? Better? Doesn't complain about this anymore. It complains now about the error type here. I will just build this to have a full trace here. From string as incompatible type for trait. Expected result. Oh, yeah, true. Result of self or self-er. And this means, and also we are not exhaustive right now, which is the next problem. Fortunately, we would have been told so. So there's an error which we will format in unknown access mode. And now we just drop in this guy, which is our input. That is that. Nice. Isn't that beautiful? Totally so. And now in process lock, we should be able to just convert these. So that's the access mode. And I actually like to write it like this. We could call it mode just to shorten it a bit. Access mode. So this one, you know, it's not just a Boolean anymore. It's really the mode itself. We have to implement this for the kind as well. So we get the string, then we parse it and unwrap it. And same thing here. Lock kind, we have to implement this still. And var, oh, we have this already. Sorry. Kind, parse, unwrap. Awesome. So here we got the values we need, and now we can just create the lock that this guy wants us to have. But before that works, we will obviously have to finish implementation of the lock kind conversion. So impl as ref string for lock kind fn as ref like this, and we match self lock kind non-blocking. We call it no wait and wait, huh? No wait lock kind blocking wait, and that is that. Impl from string for lock kind, and then we have fn from string, which takes an input string, slice, and we return a result, which is entirely generic, which is the new type that we want to create, or an error that we define. Currently it's not defined though. Its type error is, as usual, just a heap allocated string that tells us what went wrong. So we match on the input. Then it's either, oh no, sorry, we don't dereference this. It's no wait, which is an OK of lock kind non-blocking, or it's wait, which is an OK of lock kind blocking. And we have anything else, which is our error, which we format to have something along the lines of unknown lock kind. And then we put it in. Input. There we go. Nice. Good. That will do, I think. So let's see if that compiles. If we get it right. Nice, that will actually work. Cool, so now we can keep going with that one. So here we have this one, and I think all this one should do is to create a new FileLock. Oh yeah, we have to provide this log file information too. So why don't we rewrite it to something like this? Unwrap, parse. So now we can have the env log file and provide the path here, which is just a path. So this is where it all starts at. FileLock new, then we put in the path. What does it want there, by the way? It wants a path buff. So we get a string here, but I think this provides a conversion here, and then we want to create the access mode, or put the access mode in as well, which is our mode. There we go. Cool. And then we just do any lock with the respective kind. And then we unwrap. And this will either panic or not, but we do not care about that. Because what matters for the result is just whether it's a successful exit code or an unsuccessful one. So, yeah, and we will have to provide more information for the command here. And I guess I want to have something like this. This time we do not have a temp file, but we want to have a file remover, right? We want to... Yeah, we could also have multiple log files even, if we are inclined to do that. Actually, we could use the temp file, which will take care of removal, right? Yeah. And we'll take care of removal. And we'll open it for writing though, so that's kind of a problem. Yeah, so no, we don't use a temp file, we use a FileLock everywhere. So if this is an error, then we are the main driver. Actually, we don't care about the actual type of the error. So that should already run, even though it doesn't do anything. Oh, method named unwrap, not found for type result in the current scope. Unwrap doesn't exist if debug isn't supported by something here. And this is a problem here, right? So we want to derive debug, and probably for good measure, we could try partial equality and maybe even equality. And that is that. Oops. Something there doesn't work, probably because partial equality isn't implemented for IO error. Okay, remove file, FLock, true. So now this should be better. No, Now it can have what? Interprocess. That is interesting. I must have broken the... Why did it break? Interprocess lock used to work. I must have broken it somehow. Now it can have the lock. Ah. Because we are supposed to have unlocked that thing. Let's try it. Maybe unlock doesn't happen. Still doesn't work. Interesting. Very interesting. Okay. Okay. That's bad. So at least, you know, it works once. That's awesome. But here it doesn't. Damn it. Huh. I think that would run too, even though it shows us what the call process says. Result and wrap on an error. Value not present. Not present? Where is that coming from? Maybe the file has been deleted already or something? Oh, I'm dumb. This is okay for, you know, this has been alright for quite a while here. I just look at the wrong one. No. Did I... Now it worked and now this one failed? Are you kidding me? That's... because that one is also... Now I get it. They're calling... This one is executed as well. This needs to go into a separate file. Damn it. Otherwise, this one, you know, when this process calls itself, or when this test calls itself, this one will run, but also this one. So we really need a different, basically a different integration test unit for this. So source, oh no, sorry, it's in tests, process, FileLock. Like this. So we'll just remove all of that. So that one should be fine now. And now we remove this one. And this one should also be fine. We don't need temp file anymore. Open options we also don't need as raw of D, no. Command access status, yes. env, yes. Mod support, no. So that should be more like it. Oops. So now both should work. And this is yet to be used. Cool. So that's fine. Now, finally, let's get going on the driver. So we create a new, we have to set up the log file. And I think we will work on multiple ones. So I guess it's best to just have a function for this that takes a path, or that takes the options to call ourselves with, which is the kind, the mode, and the file path. And this will be a path buffer, I think. So exec self status on a path, which is a path buff that we don't even have yet. Use std path buff. And then we have an access mode and a lock kind. Like this. And we return an exit status at the very least. And now this thing moves here. And gets adjusted a bit. So this is FileLock test. I mean, just for completeness, correctness. So current XA unwrap, yes, yes, please. Then we set the log file to the path. This should, I don't know, let's see what it does. This should be able to convert itself into a string. Let's try it. Then we set the FileLock test kind to kind as ref and FileLock access mode to mode as ref. We just implemented the as ref for string methods, which should be selected automatically here due to type inference. That's very nice. Yeah, I think that is all the data that we need to pass. Then we check the exit status, and that's all we need here. So now we can start. Let's check a write lock, which is the easiest, and we have to see. Yeah, I want blocking testing as well. So maybe we are able to test this in a loop. So we have the write testing, and then we will have the read testing. Maybe we mix it, we intermix it. But most importantly, yeah, first we need a file remover. The remover, yeah, I wonder if I want this. Where's the remover? Huh, interesting. Ah, it's a new tool. Do I import that one? I do. I'm not sure about this one because it's so simple and also not very specific to the problem at hand. Yeah, it's more like a test utility, actually, because we don't use the remover anywhere. So let's kick it out. And put it into support. Because that's more like it. Path buff we have, remove file, we have now, borrow we have now. Okay, oh, borrow we have twice. Good, oops. So I think this could be doing it. Remove file. And should work for us. So let's kick this out entirely and remove it. Git rm f source util. There we go. Good, that's a bit cleaner now. And now we set up the remover. FileLock we support. Yeah, let's put it in. Mod support. And now we can use support remover, right? Let's see if that compiles. Oh, unresolved name, FileLock. Where's the process FileLock 19. Oh, yeah, I'm using the wrong names here. So that's the lock kind and access mode. Yeah, I could even shorten this a bit. I think this file is kind of redundant now. Like this. All right. Good. Function is never used, so that will be fixed soon. The remover. So let's first have a write file or something. And yeah, for the writing part, we can actually use, yeah, maybe we want to upgrade the temp file to be able to specify what kind of mode we want to have. So let's have an access mode. So now we can do read mode is access mode read, and this will be write mode is access mode write. So that said, now we can easily use a temp file and we don't need the remover anymore. So the remover is kind of unused now. We could actually remove it. So temp file, here we just need a write access mode for now. Okay. Here temp file, the remover is not used. You can kick it out. Would have to implement drop then for the temp file here. Yeah, I will build a refactor this later. Let's put a to do here. Remover. It's better as part of temp file. Like that. Good. So now, we don't want to interfere. I mean, that's a temp file, right? It puts it into the temp directory, does nothing more. So we want to be sure this is not clashing in any way. Interprocess lock write lock operation. Interprocess write file lock operation, just to be sure this doesn't clash. So that's our file. And I think we can be precise. Oh, look, it managed to do it right. Can do it like this. What? Oh, yeah. So that you have to separate test basically. And once we're done with the write test, we will be able to do something else and remove the file right away. Good. And now we make the call in blocking and non-blocking mode for that's a lock kind. For lock kind in this, which is lock kind blocking. Let's start with non-blocking. Just that one for now. So that will yield borrows of the kind, or to the respective kind we are iterating. And now exec self status. So basically in blocking, yeah, let's get the status. That's stat. The thing is, this will block. And, then these things can wait for each other. This is why previously I only tested non-blocking mode. These were deadlock right now. That's what I'm saying. So what we want to do is make this guy aware of the access mode so that we can, I mean, let's see how command can be called without blocking. What's command X, by the way? UID, GID. That's probably only there for Unix. That's interesting. I wonder how this can be used correctly, because these probably, see, that's only there if we are on Unix, so you have to be careful about this. But I think it's good to have anyway. So spawn, so spawn, so these will block, and spawn will allow us to deal with that. But we probably wanna mute it. Piped inherit null. Okay, so we do process stdio null. All right. That's cool. So yeah, I think you want to have two functions then, because the return value will change. Most of the time we are just fine with the exit status, with that particular exit status. And in a way we probably want to write the same test for the lock as well, but I think it shall be enough to assume if FileLock works, lock will work as well, because they're essentially the same. Good, so fn exec self child will support the same stuff, but return a child. Where's the command? Like that. So that's a command child, right? Yes, it is. And this will have nothing. But yeah, can we wait on that? Sure, we can wait on that. Kill. Okay, cool. It's kind of new, is it? No, it's not. It's unstable. Wait and wait with output. Oh, that's very nice. That's very cool. Really good. Because the wait with output is super important, otherwise this process may block if you don't. Oh, the STD handle to the child process, if any, will be closed before waiting. This helps avoid deadlock. It ensures that the child does not block waiting for input. Yeah, it can still block waiting for output to be read. So that's something, huh? Yeah, I think I want to have another one that says fn configure command, which takes a mutable command and then all the stuff that it should be configured with. And yeah, it will basically just be that, huh? Command env. Oh, maybe this doesn't work because of the builder pattern. Let me see. Ah, cool. This works on mutable selves. Awesome. So that's what we can work like that. Command that. So now we can configure it. And if we would return it, we could even chain this stuff, possibly, huh? Can we chain it? Could work, because it's all working on mutable selves. Yeah, I think that will work then. So we return a mutable command reference. That's a first timer for me. Let's see how that goes. So yeah, I think I will rebuild this one to use my new command configuration thing. Let's see if that even builds. Support 50. Oh, no access mode. FileLock. Use FileLock. Access mode. What do you say now? Oh, I guess there is a semicolon missing. Yes. And I might want to remove this for now. And then we need lifetimes. Okay, fine. Makes sense. Actually, this makes sense because it doesn't know which command instance is being returned. But we want to say that it's actually this one here. And that is that. So that should now be better. It's a bit better. And now the temp file creation doesn't work out anymore. Oh no, wait, here we have it. Where is it? Oh, in unit tests. FileLock tests. It's all write logs though. Because they are exclusive. Like this. Okay. Good, so now we compile again and I can try this configuration scheme. Basically, it's just configure command. Here we have the new command that we want to turn in. Oh, wait. You know, we could use an ownership pattern here. That would totally work. Let's own it. In our particular situation, that's actually better. Because we can just spare all the lifetime stuff. Do this, return the command. So now we create it here, pass in all the values, kind mode. Now it's configured. Done, done, done. And here we do the rest of it. Unwrap status. Oh, this should just work, and now it's really easy to do the rest. Can I borrow immutable local? Oops, that was not intended. Come on. This is so silly, I don't know. If I could disable something in OS X, I would disable this minimize window thing. No need for that. Okay, so yeah, this must be a damn it. This must be a mut. The cool thing is you can put the mut here, I think. And now this works. Awesome. So this is how we do it. Now we can have the same implementation, but we will do some more configuration. We will say std in, let's get stdio, here is null, stdio null, just mute it entirely, std out, std and then we spawn it, which returns a result that we just unwrap to get the child out of there. And that's the secondary mode. And that should also compile. It does. Cool. So now we can start with the non-blocking part. I would say, because the session has been going on for quite a long time. Yeah, we can even, you know, here we used any lock, and here we use the preset ones because we have to check for blocking and non-blocking modes anyway. So this one is supposed to fail. Assert, how do I do it here? Okay, assert status success or not success. Exec self status takes the path, t path, then kind clone, and yeah, let's have a mode here. Let write mode be this, so we can keep it. Yeah, maybe I just use the long one. Access mode, oh damn it, access mode, right, like so. Success. So that shouldn't be successful because we have a lock on this, a write lock. Oh, actually, we don't have a lock on this yet. And we want to check it. Yeah, let's get the lock first. Let FileLock be FileLock new. Provide a path, which is a path buff. Do I have a path buff here? Yeah, no wait, that's a path. Interesting that this automatically curses to a path here. It's probably, yeah, I don't know why that works, to be honest. Yeah, but here we want to have a path buff, right? To feed the FileLock. Yeah, in a way this shows, I mean, what we have at least is a path, but path buffs are easier to own. This is why we have a path buff here. And it even wants to own it. So right now we have a little bit of an API problem here. Path buff probably implements clone. So we can have parpathen path buff self. Cell remover path borrow clone. So that should return what we need. FileLock t path buff, then the access mode right. Okay. And now we lock it. FL. Yeah, we can, yeah, it doesn't really matter, right? We just want to have a lock on it. Try lock, unwrap, because we assume that this works. Good, so that's our lock now on the file that has just been created. Sometimes the same file is reused in the next iteration. So now we do the same thing here. Configure the call, and this must always match up, basically, huh? But I think it will. But we should also be sure that we only try this if mode is what we lock kind is what we expect it to be. Is lock kind non-blocking. Oh, like this. All right. So something doesn't work. Cannot be applied to. Oh yeah, sure. Kind is supposed to be dereferenced here. And there we go. Path. Expected path buff found path. Oh, really? Indeed, path buff. Really? Path buff. But it could work on a path more easily. A path buff can easily be converted to a path, but not the other way around. So let's use a path then. And it must be a borrow. But that's something we can easily achieve. That's fine. So, better, isn't it? Oh, don't tell me that lock kind doesn't have partial equality implemented. It doesn't. Huh. Good. So now it compiles. Ref cell already borrowed. Interesting. Wow. Where does that happen? I mean, that's a totally unrelated thing. Ref cells we use here. And the borrow should automatically... Oh, I think this is what happens. We borrow here, this keeps the borrow alive. Oh. And then this open file thing borrows again. I think this is where the problem occurs. Open file. No, I don't know. This borrow should go away. Damn it. Okay, that's a different error. But at least we have something now. So let's make a commit. So that's tests file. FileLock. Initial inter process test. It is a basis setup for extension supporting testing, which will support testing of blocking lock semantics as well. What else? Remover type was put into the test support module and will probably be removed entirely. What else did we do? Yeah, some minor fixes, I guess. Oh yeah, lock kind implemented. String conversion methods, traits for all relevant enumerations, which in our case greatly helps testing. Yeah, it's a simple form of serialization, deserialization in the end, right? Something that can easily be implemented with just a few lines, so that's why we have it. Yeah, so in short, lots of additional stuff has to happen for this to be useful. But we will do that in the next session. So thanks for watching and have a great day.